Greetings, Math 93. Okay, so we're going to take a look at lesson 5.1.1. So this is an introduction to two-way tables. And essentially, two-way tables are taking a look at the relationships between an explanatory variable and its response variable. So what I would like you to do before actually beginning this video is please make sure that you've worked through up to page, let me see here, page 3. So there should be some pages where they're asking you to kind of investigate, recall what an explanatory variable is and what a response variable is, as well as tallying some data information, which we're going to go ahead and summarize here to begin with. So in this situation that you have here, you are told that we want to see if there's some sort of connection between someone's biological sex and the amount of soda consumption that they have a day. So in this case, hopefully you kind of started to identify, well, which one is the explanatory variable, or in other words, our cause, and which one is going to be our response variable or our effect. And the way that that question is kind of worded, what we want to note is that the sex of the individual is our explanatory variable. In other words, this is going to be our cause. We want to know if someone's sex is going to determine if somehow that's triggering, like, I need to have more soda in my system every day, or I need more soda to maybe feel normal and operate. I'm assuming soda and caffeine and whatnot. So in this case, we're going to say that their response is the response variable. It's very lackluster with regards to this example. So in other words, this is our effect. And hopefully what you've done is you've gone ahead and you've tallied everything up and you've totaled those numbers out. So right now, what I'm going to go ahead and do is I'm going to look at question number 4. So I'm going to write that up in the corner so that we can see that. So for question number 4, your total numbers should have been as follows. So for females who said yes, they already told us that there are 12 females who have said yes. For females who said no, we had a total of 6 who responded no to that survey. And with regards to the males, 24 males said yes, and likewise 6 males said no, they don't have a daily soda consumption. So what you're kind of seeing here on the outskirts, so I'm just going to kind of highlight that, are just the totals. So in this case, for example, if I want to know the total for the row for yes, I would add up the 12 and the 24, and that's going to give me 36. So this tells me that there were, I'll actually write this on the side. So this 36, what this means is that there are 36 people, so male and female, who have a daily soda consumption. And then we would continue in this fashion. So the next row over, we would get a total of 12. And this would be that there are 12 people, so again, both male and female, who do not have a daily soda consumption. Now we can go ahead and we can start totaling out the columns. So for the column below, underneath female, we'll get 18. And really what this means is that there are 18 females in the survey. Note that the 18 that we have here contains the 12 women who do have a daily soda consumption and the 6 women who do not. So right now we're just totaling out how many of the people that I talked to are female. And then lastly, if we come through here, then we're going to get a grand total of just 30 males. And then it all kind of culminates, so it all will culminate here. So this corner piece, we should have 48. So what I want to know that the 48 can either be totaled using this row or it can be totaled using this column. Okay, so the 48 here is just the total number of people, again, just people, who took the survey. Okay, so the next few questions that we're gonna kind of hang out with, so specifically questions 6, 7, and 8. I do expect you to go ahead and perform number 5 on your own. We're gonna still work with this table, and so double check and make sure that you have all the work and notes down that you'd like. I'm gonna go ahead and erase this. So to save us some time, let me go ahead and kind of wipe my screen clear. Okay, so we're going to move on to question 6. So notice that the only thing that they provided to us is the bottom total row. So to read this question, essentially they're saying in this problem, you're going to make up your own values for the two-way table. So they want you to step away from the actual responses that you have. You kind of want to imagine that you've interviewed a brand new set of 48 individuals, 18 of them being female and 30 of them being male. So from here, they want you to fill in the two-way table below in a way that shows that the males and females are equally likely to drink soda on a daily basis. So in other words, I want to figure out a way to, I guess, figure out how to partition the males and the females so that if I were to take their percentages, that I would get the same percentage of women are drinking soda daily and the percentage of men are drinking the same amount of soda daily. So what I would encourage you to do at this point is pause this video and give it a try, and then come back and start the video up to watch the solution that I have. There are going to be many, many ways that you could do this solution. So I'm going to go ahead and do the solution right now, or at least one of them. So one of the things that I'm thinking of is, well, I know that I would have an equal, that they would be equally likely if I had, say, for example, 50% of the females are drinking soda daily and 50% of the males are drinking soda daily. So in that case, I might say, well, if I split the female group down the middle and get, say, 9 of them who say, yes, I drink soda daily, and 9 of them who say, no, I don't, I can kind of reproduce that for the males, who would then be broken into 15 and 15. This would then allow me to fill in these 2 empty spaces, because 9 plus 15 would then give me a 24. And we do want to make sure that, one, all the numbers line up with the totals that I have noted in black. So again, if we add 9 and 9, we do get 18. If we add 15 and 15, we do get 30. And 24 plus 24 does give me 48. So let me kind of just spend a little bit more time to talk about this idea of equally likely. So in this case, for example, if I looked at the 9 females who said yes, they have a daily soda consumption habit, if we do 9 out of 18, this would come out to 50%. I'm obviously skipping some steps, so I'm going straight to the percentage as opposed to doing 9 divided by 18, which would give me 0.5, and then converting that over into a 50%. So for the men, likewise, if I take my 15 and I divide it by that 30, I would also get 50%. And to kind of really drive this home, even though I may not necessarily have to, 50 and 50 are equal to each other. So it is equally likely whether you are male or female, that you will have a daily soda consumption habit. Okay, so really quickly, let me go ahead and clear these out so that we can kind of take a look at another example. What if I can go to the other extremes, or I can go two extremes. So say, for example, maybe you, I don't know, go to a gym and you ask people this question. And maybe everyone that you interview goes, nope, I don't have a daily soda consumption. So both the men and the women that you interview say, I don't drink soda at all, or maybe I only have it once a week as opposed to every day. That would mean that everyone else that you speak to, they're saying, no, I don't have it. So therefore, no one is actually stepping forward and either being honest, or they legitimately don't drink soda every day. And again, if we total these out, we still would get 0 on top, we get 48 on the bottom, and we can still check this. So adding down, our numbers still will total out to what I have in black. And likewise, if we were to go ahead and actually look at this, so 0 out of 18 would still result in 0%, and 0 out of 30 would also result in 0%. Again, talking about that idea of equally likely. Okay, we're going to move on to question 7. For question 7, they've decided to change this up a little bit on us. They note, we are interested in whether there is a difference between the frequency of daily soda consumption among males and females. We want to fill in the two-way table below in a way that shows that females are more likely to drink soda on a daily basis than males. So I'm just going to shorthand this right now and just say females more likely. This is our goal. So again, what they want you to do is they want you to make up your own values. So again, you want to imagine that you've gone to a different location, or you've surveyed a different group of people, and this time your results want to come out so that you're going to see that women are more likely to have a daily soda consumption habit as opposed to the men interviewed. So again, I'm going to just go kind of extreme here. So I'm going to, again, refer to the female group and say, well, if I want them to be more likely, what if I just kind of front load it and have, say, 17 out of my 18 women say that they drink soda? The reason for this is because, again, if I kind of go back to this idea of the percentage, we're going to see how large of a percentage that actually is. So if we do 17 out of the total 18 women, we would get 17 out of 18, which roughly comes out to 0.94 repeating. Okay, so if we converted this into a percentage, remember that we would kick this back, this comes out to about 94.4% if I decide to round to the 10th place of the percentage. Okay. So again, just to be clear, if I didn't do the shorthand, my decimal would look something like that. And then if I were to convert that over into its percentage, I would get that 94.4 because I would be rounding to the 10th place of that percentage. For the males, I can still shuffle that. I can shuffle those numbers around, but honestly, because I front-loaded the female response so much, I am just going to kind of be lazy and just use the same numbers that we had started off with. I'll still have my same 24 males who said, yes, I drink soda daily, and then the 6 who said no. So when we total these out, my total people who said yes will be 41, and the total people who said no will be 7. And again, what I want to note is when I total these out, I should get 17 plus 1 gives me 18, 24 plus 6 gives me 30, and 41 plus 7 gives me 48. So we're still all on the up and up. If these numbers did not total to the numbers that I have in black, then I need to make some adjustments. But now we can compare this to the male side. So again, we have 24 males out of 30 who said that they have a daily soda consumption. So 24 out of 30 would come out to 0.8, or in other words, 80%. So again, as we can see, 94.4 is larger than 80%, so we're saying that the females are more likely than the males in this situation to have a daily soda consumption habit. All right, so now we're going to go ahead and take a look at question 8. So bear with me, I'm going to clear my board so we can start fresh. Okay, so for question 8, they're just flipping this on us. Now we want to model a situation where if we were to interview 48 people, 18 of which are female, 30 of which are male, we want to make it so that the males are more likely to have a daily soda habit. So again, you can kind of do the same thing, well, there's a few ways that you could do this. So again, please keep in mind that the answers that I'm providing you are just suggestions or one of many possible ones that you could create. So as long as yours are fitting in within the specified description that they want, then you're good. So I might actually just flip it. So before, when I had females where I had 17 of them saying yes, well, what's so bad about just flipping it so that I have one female that I've interviewed says yes, and then 17 of them say no? And then I'm just going to leave the male respondents from the very beginning the same. So again, you could have done this another way. You could have maybe left the females the same, but then kind of front-loaded all the male responses into the yes field or the yes cell, and then maybe had none or very little in the no field. Again, I'll go ahead and I'll add up my total column. So I have a grand total of 25 people who said yes, and then 23 people who said no. Note that, again, 1 plus 17 is still 18, 24 plus 6 is still 30, and 25 plus 23 is still 48. So let's take a look at those percentages. So if I look at the percentage of women who said yes, we would have 1 out of 18, and that's a terrible color choice. Sorry, let me redo that. We'll go with red. So 1 out of 18. So 1 out of 18 comes out to 0.05 repeating, or in other words, that's 0.0555 forever. If we convert that over into a percentage, this comes out to about 5.6% if I round to the 10th place. For the men, very similarly, as from last time, we'll do 24 out of 30, and this comes out to 0.8, or in other words, 80%. Again, note that 5.6% and 80%, 80 is bigger between the two, meaning that men are more likely to have the daily soda habit in this situation. I hope that this helps. Please let me know if you have any questions, and yep. Good luck. Keep working through this this section. There's a second video that'll help you get going on the other half of this lesson.